I'm very happy with the digital readouts that I've added to my mini mill. There's a slider there, and I've got the one on the Z-axis off right now for a little project I'm going to do. And there's another one right here for the Y-axis. Now it works just great. Works very nice. Much better and more exact and easier to read than the dials. And I'm happy with them, except for one thing, and that's the size and the hard to read readouts. The readouts are not backlit, they're LCDs, and they're pretty dark. Now if I shine the light just right, they're not too bad, but sometimes I've got to have the light down here doing other things. I'm not looking at them exactly right, exactly square. Why? It's pretty hard to read them. So I thought I'd like to come up with a better system for the readouts. I started to investigate the mechanics and electronics and how these things work. And I stumbled across a few things the other day on the internet. And I decided that I was going to get a new Kindle tablet. Use that for a readout. They're about $90. And build a little Bluetooth transmitter to run the gauges, these sliding gauges, read them, and transmit the results of the reading to the Kindle Fire, the Android operating system on the Kindle Fire, and give me a much better readout, easier to read, and plus a few more functions to help me out in remembering some of the formula and those kinds of formulae, those sorts of things that really make the mill a lot more utilitarian and easier to work with. In other words, automate some of the math so I don't have to sit here with the calculator and calculate all day to figure out things like ring circles and that kind of thing. Okay, so that's the project we're embarking on. We'll see how we can do. During this phase, we'll test the circuit that we've put together here, the Arduino program, which is on a Arduino Uno, revision 3, and use the breadboard here to mount the connectors for the gauges, mini B USB gauges, the circuitry that surrounds that, also the AC06 Bluetooth adapter, which actually functions to the Uno as a serial input-output port. The Bluetooth connection is all taken care of by that little IC right there. Very nice. It's a kind of a independent function. So we've got the program loaded in the Uno, or a sketch they call it, and we've got it running here on the test bench. And we're going to try it now and run the app that we've downloaded onto our Kindle Fire, an $89 tablet that we bought just for this application. It's 90 bucks, I think. That's what it was. I'm pretty impressed with it, actually. I've been playing with it, and it does just about everything my $600 iPad does, so I can't complain, that's for sure. I was going to relegate that to this function to be in the DRO on the mini mill, but I think I might just use it for other functions besides. I like it so well. Now we'll give that a try. We'll hook up our tripod and we'll see how it works out. Okay, hopefully you'll be able to see this all right. I can keep the fire in the frame. We got the system running, programs running in the Uno, and there's a light flashing. You might not be able to see that light flashing on the HC06. We'll turn on the Kindle and start our DRO app. Now, see up here, the right hand corner, it says connect. So we'll connect to our HC06 hopefully. Hit the go button. There it says select a device, which the HC06 is the only one in range right now, so we'll select that. Whoop. I hit a little below it. There we go. There we go. Kind of hard to tap this thing from this angle. Alright, I'm hooked my test scale up on the Z scale right now. And you can see we have it reading a 0.715 thousandths. There we go. Get it above this light. Perhaps I can turn that light out and we'll get a little better reading on. Okay, that's much better. Alright. Now as I move the slider on the scale, you'll see that we're working properly. We're now up to 816 thousandths. That's a nice readout. I'll be able to see that and be able to read that with no trouble at all. Much better system than the little bitty readouts that came with the DRO. They're not even backlit. Plus this one has functions for drilling circles, holes in the right place for different numbers of holes at different radii or diameter circles. It's very, very advanced actually, and much better than just the little system that came with the gauges themselves. All right, so far so good. Let's try the X and the Y axes now. There we are. We've plugged our gauge into the Y axis. We go over here and slide the slider on the scale, which will slide along with the table. The Y, when we put it on the mill, it'll be sliding along with the gauge on the Y axis. And you can see that it changes as we slide it. So that one's working great. 225 thousandths of an inch right now. Very nice, very nice. I believe I'm going to like this one. And now we'll check the x-axis. We've got our scale plugged into the x-axis. Go over here and run the slider. All right, that looks pretty good. Looks real good. I think we got the circuit pretty well taken care of. Now we've got to make a more permanent circuit. It works on the breadboard. Let's make a more permanent prototype that we can actually use on the mill itself. We could use this one, but as you can see, it's kind of bulky. We've got temporary wires plugged into the breadboard all over the place. We don't really want to have that kind of action. So we'll gather our parts together and we'll start on that. We've gone through the parts drawers and pulled the parts that we're going to need to build the prototype board, along with the hand tools that we'll use. And you can see here we got the Arduino Uno that we used over there in the breadboard mock-up, and you'll notice that there's another version of that called the Nano, which I use for production. I do a lot of testing with the Uno, because it's got some associated circuitry with it there that makes that pretty handy, that I won't need on the final version. And I don't really want to sacrifice the space and have the unused parts just there taking up room, so we won't use that. Set that aside, and we're going to use the Nano. And we've got our HC06 Bluetooth module. We got the headers that we use for, actually we'll make sockets out of the black one to mount to the board with, rather than hard wiring all these little modules to the board. We've got some alligator clips that we use for heat sinks during the soldering process. And we've got some, what they call these breakout headers, breakout boards, and they allow us to conveniently get out the connections for the USB, micro, and mini B USB cables. We're going to use this prototype board. That's nothing more than a lot of holes, square grid patterns with copper foil on one side, but each connection is trying to do this without getting too much glare. Each connection is completely separate from the other, so we need to bend the wires together to connect them to complete our circuits. And that's easier said than done. It takes some messing around. But we'll do that. We'll turn that over so we don't get the glare. That'll be our circuit board for our prototype. And we may add some capacitors. We have our resistors. The resistors are pulled from our resistor stash. We won't use all of those, of course, but they're pretty close to the right values. We'll select the appropriate values out of there when we wire the circuit. And we've got our solder and some wire for the ground for the short connections, just bare wire. And a couple pieces, rolls of, there's some yellow wire, a little piece of blue and white wire that we use. I like to color code my connections, so I know when I go back through the circuit what the function is that's being performed by each section. That's an old trick I learned from my days as a radio engineer back in the tube days, where every circuit, the A circuit for the filaments and the B circuit for the high voltage and C for the bias supply were all different colors. It made it much easier to chase a electronic circuit than if you had all the same color wire. I have a story about that I may tell you sometime, but then you don't know what's going on anymore. So it's a big aid in troubleshooting and maintenance to use different colored wire for different functions. And we have a marking pencil there to help us when we determine the lengths of each of the jumper wires when we put them in place. Now we'll go to work and we'll develop our prototype. So here's our prototype. Took a couple of days to put this together, part-time. It uses two supplies that come off of the nano chip, 5 volts, which runs over to our HCO6, which we haven't put in yet. We'll put it in there now. He mounts just right in the socket. So now we've got the HCO6 in there. Nice that using this socket technology, you can plug these modules in and out, which makes it nice for testing and maintenance, and also for reliability. If you've got a problem with one of them, you can swap it with another one and figure out if that one works any better than the other one or not, because sometimes these things coming from China are a little flaky. But actually I'm pretty pleased with the quality. It comes about as good out of Shenzhen as it does out of Palo Alto or wherever Silicon Valley is, San Jose. So you can see we got the nano in there. We programmed that by hooking it to the Arduino IDE, Integrated Development Environment. And we've got the connections for the X, Y, and Z axis. Now, on this one, when I do install it, I'm going to have to use this other adapter, breakout board, because the new high gauging scales come with a micro connector rather than the mini B connector. I don't know why they have so many different connection types for that USB, but those are kind of the standard. Just that they sort of changed midstream on us. For what reason, I couldn't tell you. I guess to screw us guys up that use them as much as they could. So that's the prototype. That's what it looks like when you're finished. Now, if I were going to make these in bulk and make more than just a handful, rather than go through all of this hand measuring and wiring and soldering BS, I'd design a little circuit board about this size, and I'd send that off to a circuit board etching company. They do a pro job of making the circuit boards, but usually the first board costs you about $50, and then it's about $1 a piece after that, because they have to set their machinery up and do the initial layout work to get the first board out. Once they've done that, making multiple boards is a piece of cake. So if I were going to make 50 of these, say, which would be a very low production run. You don't, for a real production shop that would maybe making thousands of these, they'd make their own boards. They'd have their own equipment for doing this kind of thing. And I can do it by hand, but it takes longer than just doing the prototype, actually, if you do a good job of it. So this is the prototype. That's the story there. We're going to see how that works. And who knows if it works, this prototype may become my final production model, and I may put it in service and just let her rock and roll as is. It's always an option. Okay, let's plug it in and see how it works. Our prototype is wired in now. We're in power to it. And we've got the X scale hooked up. And let's see how we're doing. All right, we're having a bit of a problem there. The X scale looks like it's doing fine. Let's move it. Yeah, doing well. But it looks like now with the Y scale and the Z scale, which are not really, they're just floating is what we call that. We may need to connect another ground somewhere. Could be a current problem. We're using the power supply, power from the Nano, for the 5 volt and 3.3 volt line, and perhaps we don't have enough current there to really drive the scale. And the HC06, which runs on 5 volts, scales run on 3.3 volts, and we'll take a look at that too. But first we'll check the other two axes. We'll move our connection from the X to the Y and then to the Z. Just make sure they're all reading properly. There we have the Y scale hooked up. Looks like it's reading fine. Now the X and the Z are bouncing around on me. So that's what I expected. So far so good. Let's try the Z scale. All right, the Z scale is looking good. We move our scale, it moves all right. Getting a little bouncing on that, but could be because of all that activity on the other two scales that are not connected. So far so good. We'll keep after it, see what we can figure out here. Now we've plugged in the new scale, which uses a micro connector rather than the mini B. So that cleared up that's plugged into the x-axis. So that cleared up the x-axis, as you can see, which is the top one. The y-axis, which is still floating, has no input connected. And there we have the z-axis, which is connected to the old gauge that we took off the mill. And just to prove that the X is working, we'll run it through its paces a little. Reads out in thousandths of an inch. And the y-axis is flying all over the place. Obviously there's nothing hooked to it, so I think there's maybe a pin that needs to be grounded when there's nothing connected, which we're not going to worry about because we're going to have something connected to it all the time. But being the inquisitive sort, I still want to find out what's going on there. we'll start by putting a couple of caps on the power lines, bypass capacitors, just to be sure we're not having any kind of fluctuation problem there. In any event, we should do that, and we'll move on from there. This is the pseudo schematic that we're working from, and it's drawn up using the Arduino Uno. You can see that we have 3 volts and 5 volts coming out of the Arduino board, and we've got the 5 volts running over to our HC06 to power that, and it's hooked solidly to ground. And we've got the ground over here connected to another ground that runs to all of our USB connectors. See where it says ground, 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 and this also goes to ground. Now on D2, which is a clock, digital pin 2, we run through a voltage divider to bring out 3.3 volts. Since these gauges depend on this external readout, now it's going to be the Arduino for its clock signal. So all 3 clock signals are fed on the X, Y, and Z axis from this voltage divider between R5 and R6. I'm sorry, R4 and R5. And I used, you want to divide 5 volts to 3.3 volts, it's a ratio kind of thing. So we've done, there's not much current on this line, so it's not going to be it's not going to sink a lot of current out there, so you can just use a resistor divider network, not worry too much about regulation. So we'll put a 220 volt, 220 ohm resistor here, that's pretty standard value, and a 330 ohm here. So you got about a 3 to 2. 3 to 2 is 5 for the 5 volts, so it'll cut it here to about 3 to 3.3 volts, bring it down to ground, and that'll be our clock signal line. And I did the same thing on the driver from D1, which is the signal, Bluetooth signal going from the Arduino out to the gauge, and that's supposed to run at 3.3 volts, although they say 5 volts will run. I added another divider there. See that I don't know if you can read the writing there or not, but so that gives me actually another 3.3 volt line running out that way. Then we've got 3.3 volts. It says 3 volts here. It's actually 3.3 coming over here to the power line on each of our 3 USB connectors to go out to the 3 different eye gauging scales. And then our data read lines all are tied through a 10K resistor to ground, so they don't float when they're connected. So that looks pretty good. That's hanging right in there. We got the one going to the X, one to the Y, one to the Z. And they have a couple of capacitors across the ground line here, which C1, C2, and C3, which are not, they say you can skip those on the schematic of the prototype that Yuri built. I'm not sure about that. I'd rather have those connected, and I may also run a bypass from the plus 5, just as a little extra insurance. But this works fine on the, I don't get that fluttering on the Uno that I do get on the Nano. I've replaced this whole CPU board here with, well, it's the same CPU, but it's a completely different setup on the Nano than this on the Uno. So we'll do a little more checking. So far, so good, as they say in Denmark. We've completed our modification we mounted the 33K resistors between the signal lines and ground for pull down purposes, and we whipped our wild gauge reading problem. As you can see, we have no gauges hooked up right now, so our reading should be flying all over the place if we hadn't corrected it, and they're staying right on 0, right where they belong, all 3 axes, X, Y, and Z. So we're ready to hook it up to the mill, and let's see how she's going to look in the final installation. Alright, we've replaced the old bracket for the old readouts. We replaced that with a new wooden bracket that we made over there on the table saw. And that's where we'll mount the iPad, already the Android, the Kindle Fire. And when we fire up the Bluetooth, why, there'll be no wires connected to it, except when we have to charge it. But it runs a long time on a charge. And we'll be ready to roll. Looking good. Our new readout system, consistent of the Amazon Fire Android tablet and the little machine we built downstairs, which now I have mounted on the pegboard there for the time being anyway. It's all together and it's all working fine and calibrated. For now we're using a 5-volt power supply on the Nano, and we just have it plugged in as though we're plugged into a computer. There's plenty of juice to run it. Our scales are all mounted, calibrated. This is the Z-axis. And you can see the readouts are nice and sharp, big and bright. 0 everything. 0 set, and we'll 0 them off. Now as we move the Z-axis, you'll see it increment there. As we go up and down, it's calibrated in inches or millimeters. I've got them set to inches now. Then we've got the Y-axis, which I'm cranking back. Both of those axes are manual axis. I've got a motor on the X-axis, which makes life a little easier. All right. And we'll move our table to the right. Flip her into right and take our variable speed control and juice it up a bit. It's just like having a magic person beside you. Turn the crank. And you can see it reading up there. We'll hit the fast button. We're really corking along now. Let's just get from one end of the table to the other rapidly. Around 5.5 inches, 5.6. All right. Let's take it back the other way. Put her in, move the table to the left. You can see the legends there. Crank up our speed. Take it back to the left. So, that pretty well concludes this major part of this project anyway.